Hello friends, welcome to Anuniverse Double Two. In this video, we will discuss what is Pascal law. So let's start. Pascal law that is proved by Blaise Pascal, and the time is spent that is 1623 to 1662. So according to Pascal law, it states that the intensity of pressure at any point in a fluid intensity of pressure at any point in a fluid at rest, this is the main condition, fluid at rest is same in all direction. So for prove this law, we consider a small wedge shaped element. This is the small wedge shaped element of stationary fluid, and the fluid element is of very small dimensions. That means dx, dy and ds, these are the dimension of the small element, and its width is perpendicular to paper, so that is unity. If width that is not possible to draw on a paper, so we take is unity, and the fluid element is acted upon by two normal pressure force and vertical force due to weight. So I repeat this line, this is important. The fluid element is acted upon by the normal pressure force and the vertical force due to weight. So here this is the small fluid wedge shaped element, and it is dx, dy and ds. So now consider px, py and pz are intensity of pressure acting on the faces AB, BC and AC respectively. So we can say this is the px, that is the normal pressure force that is acting on the face AB. This is py, that is acting on the face BC, and this is pz, that is acting on the face AC, and this is the vertical force that is acting in downward direction due to weight. So this is the diagram for pressure on a fluid element, and this is on force on a fluid element. So now the force on the face AB, that is Fx, this is equal to the product into area, product of pressure into area. Pressure on the face AB, that is Px, dy is its dimension, and 1 is that is unity as we take the width, so it becomes Fx equal to Px dy 1. And on a BC face, that is Fy equal to pressure into area, so the pressure that is acting on the face, that is Py into dx into width, that is 1, so Fy equal to Py into dx into 1. Now on the face AC, so on this face the dimension is that is a ds, width is 1 and force that is acting Fz, and this is the pressure force Pz acting on this AC face, so Fz equal to Pz into ds into 1, so ds into 1, this is the area, Pz is the pressure. So now let angle BCA, this is the angle BCA, this is angle theta, and from this triangle we can say sin theta equal to AB upon AC. AB is the perpendicular, AC is hypotenuse, so AB upon AC, and AB equal to dy and AC equal to ds, so dy upon ds, and so it becomes dy equal to ds sin theta, or from here we can see AB equal to AC sin theta, and on the face AP the forces are Px dy into 1 equal to forces on AC, that is Pz ds sin theta, so Pz ds sin theta. So again in terms of cos theta that is BC, that is the base, AC hypotenuse, so BC upon AC, and the dimension of BC that is dx and dimension of AC that is ds, so it becomes dx equal to ds cos theta. And if we write here BC equal to AC cos theta, the force on the BC, that is Py dx into 1, equal to force on AC, that is Pz ds into cos theta. So I try to repeat, force on face AB, that is Px into area of face AB. Px is the normal force acting on the face AB into area, that is dy into 1. So that is Px into dy. As we can see, this is Px into dy. Now force on face BC, so that is Py into dx. So force on BC, that is Fy equal to Py dx. And force on AC, that is Pz into ds. As we already discussed, Pz into ds. Now the weight of the fluid element that is acting in downward direction, fluid element, that is ABC, so that is equal to area of triangular element into depth into specific weight, into specific weight. So as we know, the specific weight, this is the specific weight, this is normally equal to weight of the fluid upon volume of the fluid. And if we take with this side, then it becomes volume into specific weight, volume, that is area into depth into specific weight. So area, that is the area of triangular element, depth, that is h, into specific weight, that is small w. So it is the right angle triangle, the area of this right angle triangle, that is the 1 upon 2 into base into altitude or height, base that is BC, altitude that is AB, into 1 into W. Okay. So 1 by 2 into BC into AB into W. So BC equal to dx, AB equal to dy, and that is W. So the weight of the fluid element 1 by 2 dx into dy into W. And it acts through the center of gravity, because as we know, the weight of any element that is acting at the center of gravity, at the center point of this triangle. So there must be force equilibrium. So the forces in the horizontal and vertical direction must balance. Now resolving the force in x direction, that is horizontal. So we have in x direction, that is this is in x direction, px dy, that is equal to fz sin theta. So how this value we get? We have a fz that is acting on AC. It has two components, one is horizontal direction, one is vertical direction, and this is perpendicular, this is angle theta. Okay, so if we take this side, so from this triangle we get this horizontal component, this is the horizontal component, this is vertical component, and in this triangle it as perpendicular, it act as base. So from this triangle we get the force in horizontal direction, that is fz sin theta, that is this line, that is equal to fz sin theta. So here px dy equal to fz sin theta, and the value of fz, that is pz ds sin theta, and ds sin theta, as we can already discussed, equal to dy. So substitute here px dy equal to pz dy, cancel dy, then px equal to pz, this is equation 1. And similarly resolving the forces in y direction vertically. So in y direction we have a, this is in upward direction, that is in y, py dx. So this is py dx, and there is weight also acting in the y direction, that is weight of the fluid element, plus Fz cos theta. Now in vertical downward, that is this equal to Fz cos theta. So W plus Fz equal to Pz ds, W plus Pz ds cos theta, and ds cos theta, that is equal to dx, as we discussed. Dx equal to dx cos theta. So that is, as we proved here, dx equal to ds cos theta. So from here ds cos theta, that is equal to dx, and w, that is 1 by 2 w dx dy. But the fluid element is very small, hence weight is negligible. So that's why dx dy w, that is equal to 0. If it is equal to 0, then py dx equal to pz dx. Now cancel dx, and finally we get py equal to pz. So this is equation 2. So from equation 1 and 2 we can write px equal to py equal to pz, and this is a result which is independent of angle theta, and it follows that pressure acts equally in all direction in a stationary fluid and has same magnitude in all direction. This result is applicable to fluids in motion as well as fluids at rest, since pressure is a scalar quantity, not a vector quantity, and pressure is the compressive force per unit area, and it gives the impression of being a vector. However, pressure at any point in a fluid is the same in all direction. It has magnitude but not a specific direction, and thus it is a scalar quantity. And here we want to know about the variation of the pressure. This is the pressure of fluid at rest increase with depth. When we are moving from top to bottom, this is free surface of the liquid, and here h equal to 0. And when you are moving downside, the pressure is going on increase. So it will come as no surprise to you that pressure in a fluid at rest does not change in horizontal direction. In horizontal direction it remains constant, and pressure in a fluid increases with depth because more fluid rests on deeper layer, and the effect of this extra weight on a deeper layer is balanced by an increase in pressure. So in this video we have learned how to solve the Pascal law, how to get the result of Pascal law. So here also we need to discuss the application of Pascal law. Pascal also knew that force applied by a fluid is proportional to the surface area. He realized that two hydraulic cylinders of different areas could be connected, and the larger could be used to exert a proportionally greater force than that applied to the smaller. So Pascal's machine has been the source of many inventions that are a part of our daily lives, such as hydraulic brakes and lift. So friends, if you like this video, share with your friends and students. Subscribe Anuniverse 22 for getting the notification for uploading of videos on various topics of mechanical engineering. Thanks for watching. Have a nice day.